So in case of electrochemistry, today we are going to start with second session, and in today's session we are dealing with discussion of these two important points. What is first one? What are the sign conventions to represent electrochemical cell on paper? There are certain rules which we are going to discuss. What is second point? Depending upon construction, there are different types of electrodes, because throughout this chapter known to be electrochemistry, we have to discuss different electrodes, different type of cells. So this is today's session. So let us start with. So this is first important point throughout this chapter, very important for theoretical discussion, numericals as well as for MCQs. What about first sign convention? So before proceeding with sign convention, once again we define this one, electrochemical cell. So what happens in case of electrochemical cell? Cell which converts chemical energy into electrical, that type of cell is called as electrochemical cell. Now check first sign convention. What is this? Whenever we are dealing with electrochemical cell, which electrode act as anode? Just in previous session we discussed. Negative electrode act as anode, and in case of anode always there is what type of reaction occurring? Oxidation, that is loss of electron. Such electrode on paper always return towards left hand side. So tell me, a negative electrode acting as anode at which loss of electron, that is oxidation, takes place, it always return towards left side. Now tell me reverse case, in case of cathode, a positive electrode which is acting as cathode, at which what happen? Gain of electron occurs, that is nothing but reduction, and such electrode on paper always return towards right hand side. So once again, positive electrode behave as cathode, shows gain of electron called as reduction, such electrode you have to represent towards right hand side. Then what about third important sign convention? Whenever we are dealing with half cell, that is electrode in contact with its ionic solution, then what is third rule? Direct contact between rod and surrounding solution, it is denoted on paper by single vertical line. Means you have to indicate such type of line, single vertical line. What about next point? Whenever we are dealing with indirect contact between two electrolytic solutions, then one can represent double vertical line. So single vertical line is used to indicate direct contact between rod and surrounding solution. Double vertical line is used to indicate indirect contact between two electrolytic solutions. What about next point? Water may be the understudy solutions. You have to indicate their concentration in round bracket. What do you have to write here? C1 for first solution, C2 for second solution, or in some text or reference book, instead of concentration this word is used, that is activity A1 for first solution, activity A2 for second solution. What about next rule? Whenever we are dealing with this special type of electrode called as gaseous electrode, then what is the role of platinum wire? Platinum wire is used to establish electrical contact, and that platinum electrode should be represented in the electrode representation. What is last but important one? In case of electrochemical cell, what happen? Electrons always flows from negative electrode to positive electrode. Means flow of electron is always from anode to cathode. So tell me once again rapidly. A negative electrode acting as anode showing oxidation return towards left hand side. Positive electrode which is acting as cathode, at which reduction occur, return towards right hand side. What is use of single vertical line? It is used to indicate direct contact between rod and surrounding solution. What is use of double vertical line? It indicates indirect contact between two electrolytic solutions. Next point regarding activity or the concentration. Whatever may be the activities or concentration of two solutions, you have to indicate in round bracket, like C1, C2 respectively, or A1, A2 respectively. In case of gaseous electrode, what is use of platinum wire? It is useful to establish electrical contact, and it is compulsory to represent that platinum wire in electrode representation. And last important one, Electron always flows from negative electrode to positive electrode, that is from anode to cathode. So try to remember these important sign conventions regarding representation. Then next point, what is this? What are the different types of electrode? So in case of board exam, 3 marks question will be there, or at least 2 mark question will be there. What are the different types of electrode? Or in case of MCQ discussion, example is given to you, you have to identify type of electrode, or reverse will be the case. So let us start with different types of electrodes. So before starting with types of electrode, try to remember what is criteria for this classification. Classification of electrode into 5 different types. That classification based upon construction part. How that electrode was constructed, depending upon that there are different types of electrodes. So let us start with first one. What is first type of electrode in front of you? Metal ion electrode. What word we are using here? Metal ion electrode. So can you able to tell me definition by observing these two examples? What is first example? Zinc in contact with ZnSO4 solution, or zinc in contact with Zn plus 2 solution. What is second example? Copper ion in direct contact with copper. So these are what type of electrodes? Metal ion electrode. So how to construct definition for metal ion electrode? That construction in which what happen? Metal rod is deep in its ionic solution. That construction called as metal ion electrode. What is the example? Zinc rod is in direct contact with Zn plus 2 ion. Means zinc rod deep in zinc sulfate solution, that constitute what type of electrode? Metal ion electrode. Check next one. Second type of electrode known to be amalgam electrode. What about amalgam electrode? Suppose we check this example. Zinc amalgam in contact with Zn plus 2. Sodium amalgam in contact with Na plus ion, or sodium ion. These two indicate what type of electrode? Amalgam electrode. So keep in mind for MCQs, those active, that is highly active metals, these cannot be directly used as electrode. So in order to decrease their activity, they convert into their amalgams. Suppose we take sodium. So it convert into sodium amalgam, which is in direct contact with Na plus ion. So such electrode is known to be amalgam electrode. Let us start with third type of electrode. What is third type? Known to be gas electrode. So in sign convention part, just we discussed, platinum wire is used to make electrical contact. So what happens in case of gaseous electrode? Pure and dry H2 gas or any another gas is bubbled on particular electrode at certain atmospheric condition and concentration. Such construction is called as which electrode? Gas electrode. So tell me example. Pure and dry H2 gas at exactly 1 atmospheric pressure. It is bubbled on platinized platinum wire and it is in direct contact with HCl. And what is molarity of HCl? 1 molar. Keep in mind for MCQ also, these are two important conditions. Pressure must be 1 atmosphere. What is molarity of HCl? 1 molar. Next type. Another important type of electrode, metal sparingly soluble salt ion electrode. So three spaces are there. What is first one? Metal. What is second one? Salt of that particular metal. What type of salt? Sparingly soluble salt. And what is third species? Ion. It may be cation or anion. So can you tell me from class 11, chemical equilibrium, ionic equilibrium, what is sparingly soluble salt? That salt which is less soluble, or the salt which is dissolved to less extent, that is sparingly soluble salt. Check example. This is what? Silver metal. What about AgCl? It is sparingly soluble salt and it is in direct contact with either Ag plus ion or Cl minus ion. When it is reversible to Ag plus, it becomes cation electrode. When it is reversible to Cl minus ion, it becomes anion electrode. So remember, what is fourth type? Metal sparingly soluble salt ion electrode. Next type, oxidation reduction electrode. So example itself suggests definition. Are you able to tell me definition? What does this indicate? Platinum Fe plus 2, concentration C1. Direct contact with Fe plus 3, concentration C2. So such type of construction called as oxidation reduction electrode. Why to use this word oxidation reduction electrode? Check this one. In class 11, you already came across redox reaction. What this indicate? Conversion of Fe plus 2, that is ferrous ion, into Fe plus 3, that is ferric. This change is accompanied by loss of electron. So what loss called as oxidation. What about reverse one? Ferric ion converted into ferrous. It is accompanied by gain of electron, and what gain of electron called as reduction. So such type of construction become oxidation reduction electrode. What you have to remember here? In case of oxidation reduction electrode, what happen? Same metal present in two different oxidation state, and along with that you have to represent their concentration. So this is known to be what type of electrode? Oxidation reduction electrode. So these are the 5 different types of electrodes. Then we will shift towards last important part, that is definition part, which we are going to use in different numericals as well as MCQ discussion. What is very first term? Known to be electrode potential, or in some cases what we can make use here? Single electrode potential. Tell me, potential develop across electrode when we consider this type of construction. Suppose this is vessel containing solution. This is what? Electrode. So this is nothing but half cell, that is zinc in contact with Zn plus 2 ion, or zinc in contact with ZnSO4 solution. So potential develop across such electrode, it is called as electrode potential. Then check second one. What is this? Half cell. Just we define here. What is half cell? Suppose we take this construction. This is what? Zinc rod. This zinc rod is in direct contact with which solution? Zinc sulfate solution. So such assembly is called as half cell. Tell me, what is half cell? Construction in which rod or electrode is in direct contact with its ionic solution. This is known to be half cell. What is the example? Zinc in direct contact with zinc sulfate indicate zinc half cell. Similar will be the condition regarding copper half cell. What about third definition? Half cell reaction. So wording itself suggests definition. What is half cell reaction? Whatever may be the reaction occurring in half cell, that is known to be half cell reaction. If we are dealing with zinc half cell, tell me, zinc shows tendency to lose 2 electron in order to form which ion? Zn plus 2 ion. What loss called as? Oxidation. So this is called as which reaction? Oxidation half cell reaction. If we are dealing with copper half cell, what happen? Cu plus 2 ion accept 2 electron to form metallic copper. So what gain of electron called as? Reduction. And this reaction called as reduction half cell reaction. So what is third one? Reaction occurring in half cell. It may be oxidation or reduction, that is half cell reaction. Next point. What is another important definition? Cell. How to define cell? When we connect two half cells together, that constitutes cell. But what about this combination? Combination of two half cells in such a manner so that what happen? In one half cell there should be oxidation, in another half cell there should be reduction. So try to remember Daniel cell. This is the example of particular cell. That is, it is combination of two half cell. One is zinc half cell, another is copper half cell. So that assembly is called as cell. What about next term? Known to be oxidation potential. How to indicate this on paper? E oxidation. oxidation potential. So try to remember, potential develop across electrode due to oxidation reaction. This is known to be oxidation potential. If we take this construction, zinc in contact with Zn+2 solution or zinc sulfate solution, what happen? There is loss of electron. So whatever may be the potential developed across this electrode due to oxidation, this become what type of potential? Oxidation potential. Check reverse case. What is reduction potential? Suppose we take copper half cell. What happen? Cu+2 ion accept 2 electron to form metallic copper. So potential develop across electrode due to which one? Gain of electron. This is called as which potential? Reduction potential. Let us shift towards next definition. What is this? EMF of the cell. It is denoted on paper by E cell. Can you construct definition? E cell equal to this total sum. E oxidation plus E reduction. So tell me definition. What is EMF of the cell? Sum of oxidation potential and reduction potential. This is called as EMF of the cell. Try to remember this simple formula. E oxidation plus E reduction gives you E cell. What about next one? That is standard oxidation potential. We already defined these two terms. Oxidation potential, reduction potential. What about this symbolic notation? E naught oxidation, E naught reduction. So in addition to responsible factor, oxidation and reduction, we are going to make use of two important conditions. What is that? Potential develop across electrode. Due to which reaction? Reduction. At what temperature? 298 Kelvin. And solution in which that electrode is dipped, that solution should have unit concentration. That is 1 molar. So construct wording. Potential develop across electrode due to oxidation reaction at 298 Kelvin when it is deep in solution having molarity 1 or unit concentration, that become standard oxidation potential. So can you tell me standard reduction potential means what? Once again, responsible factor reduction. Temperature remains same 298 Kelvin. Molarity remains same 1 molar. So tell me wording. Potential develop across electrode due to which reaction? Reduction. At what temperature? 298 Kelvin. And what should be concentration? Unit or molarity should be unity. That is known to be standard reduction potential. Now check few definitions. What about this one? Standard reduction potential just we defined. What is last one? Standard EMF of the cell denoted on paper by E naught cell. So these are the three important relations. Try to remember for MCQs. What about first one? What we can write here? E cell 0 equal to, what is this sum? E0 oxidation plus E0 reduction. So tell me first one. Sum of standard oxidation potential and standard reduction potential. This is called as standard EMF of the cell. But as per this condition, which one? E0 oxidation equal to minus E0 reduction. Means what? Magnitude remains same, only change of sign. So by using this condition, what we can consider here? Standard EMF of cell can be calculated as this one. Which one? E0 oxidation left hand side minus E0 oxidation right hand side. What about another one? E cell 0. Whenever reduction potential is given, E0 reduction right hand minus E0 reduction left hand. So what you have to make use here? E0 oxidation LHS, RHS. E0 reduction RHS, LHS. So try to remember this one. Left hand side, right hand side, right hand side, left hand side. So try to remember last important definition, standard EMF of the cell.